Hello students, welcome to this lecture 1 pair of linear equations. So in this lecture we will discuss pair of linear equations in two variables. Okay, so in our previous classes we have already studied about linear equations in one variable. Okay, so in this lecture basically we'll cover introduction of pair of linear equations in two variables and the graphical method of solution of a pair of linear equations. Okay, so let's start. So you have already studied linear equation in one variables. Okay, so linear equations in one variable basically are involved only one variable. Okay, that variable may be x or y or u or v e s t. Okay, so linear equations in one variables can be written as ax plus b is equal to 0. Okay, so ax plus b is equal to 0. This is actually a linear equation in one variable. Okay, so here you see the variable is x. Okay, so this linear equations actually in one variable, and here a and b are real numbers, and then linear equation in two variables. So if we have a linear equation in two variables, then that equations mainly will involve two variables. Okay, that may be x, y, u, v, s, t, that likes. So linear equation in two variables can be written as ax plus by plus c, this is equal to 0. Okay, so here this equation is a linear equation in two variables. Okay, here the variables are x and y, and a, b, c are real numbers. Okay, now pair of linear equation in two variables. So what does mean pair of linear equation in two variables? Pair means two. Okay, so you all know pair means two. So if we have two linear equations in two variables, okay, then that are called pair of linear equations in two variables. Okay, so in generally we write pair of linear equation in two variables like a1x plus b1y plus c1, this is equal to 0, and a2x plus b2y plus c2, this is equal to 0. So these equations in two variables are called pair of linear equations in two variables. Okay, now here we have to show that x is equal to 2 and y is equal to 1 is not a solution of the system of simultaneous linear equations. 2x plus 7y, this is equal to 11, and x minus 3y, this is equal to 5. Okay, so how can we show that x is equal to 2 and y is equal to 1 is not a solution of this system of simultaneous linear equation? Okay, so basically we have to check by substituting x equal to 2 and y is equal to 1 in this equation. If x is equal to 2 and y is equal to 1 satisfy these two equations, then we will call x equal to 2 and y is equal to 1 the solution. Okay, if x is equal to 2 and y is equal to 1 does not satisfy at least one equation, okay, then x equal to 2 and y is equal to 1 is not a solution of this system of simultaneous linear equations. Okay, so now check by substituting x equal to 2 and y is equal to 1. So if we substitute x is equal to 2 and y is equal to 1 in this equation, then we'll get 2 times 2 plus 7 times 1, and this is equal to 4 plus 7, and this is equal to 11. Okay, so here by substituting x equal to 2 and y is equal to 1, it satisfied this linear equations. Okay, but if we substitute the value of x is equal to 2 and y is equal to 1 in second equation, then in left hand side you will get 2 minus 3 times 1, and this is equal to 2 minus 3, and this is equal to minus 1. Okay, but in this equation we have in right hand side 5. Okay, so right hand side this is equal to 5. So here left hand side does not equal to right hand side. Okay, since left hand side does not equal to right hand side, so x equal to 2 and y is equal to 1. So therefore x equal to 2 and y is equal to 1 does not satisfy equation x minus 3y is equal to 5. Okay, so here you see x equal to 2 and y is equal to 1 does not satisfy the second equation. Okay, so that x equal to 2 and y is equal to 1 is not a solution of the system of simultaneous linear equations. 2x plus 7y is equal to 11 and x minus 3y is equal to 5. Okay, so we have proved. Now we'll discuss about inconsistent pair of linear equations and consistent pair of linear equations. Okay, so when our system of pair of linear equations, when a pair of linear equations in two variables are called inconsistent pair of linear equations. Okay, and when a system of pair of linear equation is called consistent pair of linear equations. Okay, so if we have a pair of linear equations which has no solution, okay, then this pair of linear equation is called an inconsistent pair of linear equations. Okay, if a pair of linear equations in two variables which has a solution is called a consistent pair of linear equations. Okay, so when solution does not exist, that case the pair of linear equations is an inconsistent pair of linear equations. Okay, when a pair of linear equations solution exists, for a pair of linear equation solution exists, then the pair of linear equations in two variables is called a consistent pair of linear equations. Okay, inconsistent means solution does not exist. Consistent means solution, at least one solution exists. Okay, that may be unique or infinitely many. Okay, so now let us discuss this example. Okay, so in this example here basically Akhila went to a fair in her village. Okay, and she wanted to enjoy rides on the giant wheel and play hoopla. And here hoopla means what? Hoopla, a game in which you throw a ring on the items kept in a stall, and if the ring covers any object completely, then we will get that object. Okay, so the number of times she played hoopla is half of number of rides she had won the giant wheel. Okay, so here we have given this information, the number of times she played hoopla, this is half of the number of rides she had won the giant wheel. Okay, so now here you see she is Sakila. Okay, and she went to a fair in her village and she is playing hoopla. Okay, so now if each ride cost ₹3 and a game hoopla cost ₹4, how would you find out the number of rides she had and how many times she played hoopla, provided she spent total money ₹20? Okay, so maybe we will will try it by considering different cases. Okay, and if C has one right, is it possible or is it possible to have two rights, and so on? Or we can represent such situation as linear equation in two variables, right? So here we have given each right cost, that is rupees 3, and game of hoopla cost rupees 4, and C paid 20 rupees. Okay, and here we have to find the number of rides C had and how many times C played hoopla. Okay, so we can represent this equation as linear equation in two variables. Okay, so let us try this approach. Here we denote the number of rides that Akila had by X. Okay, and the number of times she played hoopla by Y. Okay, and now the situation can be represented by the two equations. We know the number of times she played hoopla, that is that is half of the number of rides she had. Okay, so here we get this linear equation y is equal to half time x. Okay, and we know she spent rupees 20. Okay, so you get 3x. You know each rides cost rupees 3 and played hoopla cost rupees 4. Okay, so you will get this equation 3x plus 4y, this is equal to 20. Okay, so here you can be represented by the two equations, y is equal to half x, and naming this equation 1, and 3x plus 4y, this is equal to 20. Okay, and naming this equation 2. So can we find the solution of this pair of linear equation? So here we get basically a pair of linear equations. Okay, so now question, can we find the solution of this pair of linear equations? So these are several ways of finding this, which we will study in this chapter. Okay, so in this chapter basically we'll study how to find the solutions of a pair of linear equations. Okay, so we will see in our upcoming section. Okay, so there will see some methods for finding the solutions of this pair of linear equations. Okay, so a pair of linear equations which are equivalent has infinitely many distinct common solutions. Okay, so if we have a pair of linear equations and the two linear equations are basically equivalent to each other. Okay, so that case a pair of linear equations has infinitely many distinct common solutions. Okay, so such a pair is called a dependent pair of linear equations in two variables. Okay, so if we have such a pair, then this pair is called a dependent pair of linear equations in two variables. Okay, so basically here the two equations are actually equivalent to each other. Okay, and here one equation is dependent to other equations. Okay, so that is why this pair of linear equations is called a dependent pair of linear equations in two variables. Okay, and here note it down, a dependent pair of linear equations is always consistent. Okay, that means if we have a dependent pair of linear equations, then the pair of linear equations will have at least one solution. Okay, at least one solution. Okay, so that a dependent pair of linear equations is always consistent. Okay, so now we can now summarize the behavior of lines representing a pair of linear equations in two variables and the existence of solutions as follows. Okay, so here we'll now summarize here the geometrically. Okay, so graphical method of solutions of a pair of linear equations. So how can we how can we find solutions of a pair of linear equations by graph that we'll here discuss. Okay, so the lines may intersect in a single point. In this case, the pair of equations has a unique solution. That means the pair of linear equations has exactly one solution. Okay, so when the lines intersect in a single point, then this pair of linear equations is basically called consistent pair of equations. Okay, and the second, the lines may be parallel. The lines may be parallel to each other. Okay, so in first one we have the lines may be intersect in a single point. That case, the pair of equations has a unique solution. And in second one, we have the line may be parallel to each other. Okay, parallel to each other. That case, the equations has no solutions. Okay, and this pair of linear equations is called inconsistent pair of linear equations in two variables. Okay, in third one, the lines may be coincident. That means the two lines are coincident. Okay, so in this case, the equations have infinitely many solutions. Okay, and this pair of linear equations is basically called dependent pair of linear equations. And we know a dependent pair of linear equations is always consistent. Okay, so when the line coincide to each other, that case the pair of linear equations has infinitely many solutions. Okay, and the pair of linear equations is consistent pair of linear equations. Okay, so now consider the following three pairs of equations, and here we'll check they are intersect to each other or coincide or parallel. Okay, so here in first one we have given this pair of linear equation x minus 2 this is equal to 0 and 3x plus 4y minus 20 this is equal to 0. Okay, so here you can check these pair of linear equations. So this pair of linear equations are intersect at exactly one point. Okay, so this pair of linear equations actually intersect to each other. So this pair of linear equations has unique solutions. Okay, and in second one we have these two pair of linear equations, and you can check graphically they are actually coincide to each other. Okay, so you can check here this equation this is 2x plus 3y minus 9 is equal to 0, and this is 4x plus 6y minus 18 is equal to 0. Okay, so if we multiply 2 in equation 1, then we will get equation number 2. Okay, so here the equation number 2, here this equation basically depends on the first equation 2x plus 3y minus 9 is equal to 0. Okay, so here they are actually dependent pair of linear equations, and we know if we have a dependent pair of linear equations, then they are actually coincide to each other. Okay, so the lines coincide to each other, and this pair of linear equations have infinitely many solutions. Okay, and in third one we have this pair of linear equations x plus 2y minus 4 this is equal to 0 and 2x plus 4y minus 12 is equal to 0. Okay, so these two lines are parallel to each other. Okay, so the lines are parallel to each other, and we know if we have two lines that are parallel to each other, that case the pair of linear equations has no solutions. Okay, so for this pair of linear equations we'll have no solutions. Okay, now let us now write down and compare the values of A1 by A2, B1 by B2 and C1 by C2. Okay, so we can compare the given pair of linear equations with the general form of pair of linear equations, that is A1x plus B1y plus C1 is equal to 0 and A2x plus B2y plus C2 is equal to 0. Okay, and if we find the values of A1 by A2, B1 by B2 and C1 by C2. Okay, A1 by A2, B1 by B2 and C1 by C2 in all the three examples. Okay, so here A1, B1, C1 and A2, B2 and C2, they denote the coefficient of equations given in the general form. Okay, so we know the general form, that is actually A1x plus B1y plus C1, this is equal to 0, and A2x plus B2y plus C2 is equal to 0. So this is the general form of a pair of linear equations. Okay, so now if we compare this pair of linear equation with this pair of linear equation, then we'll get the values of A1, B1, C1, A2, B2, C2. Okay, and then we can find the values of the ratios A1 by A2, B1 by B2 and C1 by C2. Okay, and if A1 by A2 does not equal to B1 by B2, okay, then graphically we can represent this pair of linear equations as the lines are intersecting. Okay, the lines are intersecting to each other. Okay, so for this pair of linear equations, so actually here the ratios A1 by A2 does not equal to B1 by B2. Okay, so here A1 by A2 is equal to 1 by 3 and B1 by B2 is equal to minus 2 by 4. Okay, and they are not equal. So actually the lines intersecting, they are intersecting lines. Okay, and if we algebraically interpret, then you can say this pair of linear equations has exactly one solutions, that is unique solutions. Okay, unique solutions. And now if you see second example, so here we have 2x plus 3y minus 9 is equal to 0 and 4x plus 6y minus 18 is equal to 0. Okay, so here if we compare this pair of linear equations with the general form of pair of linear equations, then we will get the value of A1 is equal to 2, A2 is 4 and B1 3, B2 6, C1 minus 9 and C2 minus 18. Okay, and then the ratios A1 by A2, B1 by B2 and C1 by C2. So the ratio of A1 by B2, this is equal to 2 by 4 and the ratio B1 by B2, this is equal to 3 by 6. Okay, and the ratio C1 by C2, this is equal to minus 9 by minus 18. Okay, and here you can see all the ratios basically equal, that is A1 by A2, this is equal to B1 by B2 and this is equal to C1 by C2. Okay, so when this condition hold, then the lines coincide to each other. Okay, that case the lines coincide. So here we'll get graphical representation of this pair of linear equations, that is coincident lines. Okay, when the lines coincide to each other, that case we can say algebraic interpretations, the pair of linear equations will have infinitely many solutions. Okay, now if we see third example, so here we have given this linear equations x plus 2y minus 4, this is equal to 0 and 2x plus 4y minus 12 is equal to 0. Okay, so here if we compare this equation with the general form of pair of linear equations, then we will get the value of A1 is equal to 1, B1 is equal to 2 and C1 is equal to minus 4. Okay, and A2, this is equal to 2, B2 is equal to 4 and C2 is equal to minus 12. Now the ratios A1 by A2, this is equal to 1 by 2, B1 by B2, this is equal to y4, and c1 by c2 is equal to minus 4 by minus 12. Okay, and here you can see a1 by a2, this is equal to b1 by b2, but it does not equal to c1 by c2. Okay, so the lines are actually parallel to each other. Okay, when this condition holds, then the lines are actually parallel lines. Okay, so graphical representation of this pair of linear equations basically parallel lines. Okay, and if we say if you think about algebraic interpretations, okay, then this pair of linear equations actually will have no solutions. Okay, when two lines are parallel, then the solution there is no solutions for that pair of linear equations. Okay, so now from the table above you can observe that if the lines represented by the equations a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0 are intersecting, then a1 by a2 does not equal to b1 by b2. Okay, and the pair of lines are coincident, then a1 by a2 this is equal to b1 by b2 and this is equal to c1 by c2. Okay, and they are parallel, then a1 by a2 this is equal to b1 by b2 but does not equal to c1 by c2. Okay, so let us see this example. So in this example we have to check graphically whether the pair of equations this is consistent. If so, then we have to solve them graphically. Okay, so we have given this pair of linear equations x plus 3y is equal to 6 and 2x minus 3y is equal to 12. Okay, so here if we draw the graph, here you can draw the graph that we have discussed in our previous classes. Okay, so you can easily draw the graph of x plus 3y is equal to 6 and 2x minus 3y is equal to 12 by taking some values of x and y. Okay, so if we draw the graph of x plus 3y is equal to 6, then you will get this line that will intersects at a point 0 comma 2 at x y-axis and 6 at b point 6 comma 0 at x-axis. Okay, so this line is basically x plus 3y is equal to 6 lines. Okay, and here if we draw the graph of 2x minus 3y is equal to 12, okay, then this graph basically intersects at x-axis at 6 comma 0 point and it intersects at y-axis at 0 comma minus 4. Okay, and here we know here these two lines intersects at point B, that is 6 comma 0. Okay, so the pair of linear equations intersects at 6 comma 0. Okay, so here you can draw the graphs of equation 1 and 2. For this we find two solutions of each of the equations which are given in table 3.2. here you can see in table 3.2. okay, so here when you take x equal to 0, then you will get y2, x equal to 6, then y0. okay, and you can plot the point you can plot the point 0 comma 2 and 6 comma 0. okay, then you will get a line. Okay, and now for second equation, if we take the value of x is 0, then we'll get y is minus 4, and if we take x is 3, and then we'll get the value of y is equal to minus 2. Okay, and if we plot the point 0 comma minus 4 and 3 comma minus 2, then you will get a line which intersects at x-axis at 6 comma 0 and at y-axis 0 comma minus 4, and you will get this line. Okay, so after plot the points a 0 comma 2, b 6 comma 0, p 0 comma minus 4 and q 3 comma minus 2 one graph paper and join the points to form the lines ab and pq that's shown in figure. Okay, so here we observe that there is a point b 6, 0 common to both the lines AB and PQ. Okay, so the solution of the pair of linear equations is x is equal to 6 and y is equal to 0. That is, the given pair of linear equations is consistent pair of linear equations. Okay, so I stop here this lecture. Thank you very much to all of you.